Hi again. Let's take a look at 7.11 now, problem 7.11. Describe how non-disjunction in human female gametes can give rise to Klinefelter and Turner syndrome offspring following fertilization by a normal male gamete. Okay, so we're going back a little bit to chapter 2 with meiosis. And we haven't really talked about non-disjunction yet. And non-disjunction is fairly easy. It's a fairly easy concept. So let's start with a primary oocyte in a human female. So a primary oocyte, and let's look at, say, the X chromosome here. So here's an X, and let's say this is metaphase, and we have the two X chromosomes with the sister chromatids aligned on the metaphase plate. Okay, so this will undergo meiosis 1, and we could have non-disjunction occur at this point, but let's just assume that everything is gonna, work normally during meiosis 1. It doesn't have to, but let's assume in this case it is working normally. So one X chromosome goes this way, and then the other one goes into that polar body, that first polar body. And the polar body is really small. You can hardly fit that chromosome in there. First polar body. And this one right here, this is the secondary oocyte. And I don't know why that stands for secondary, that 2 degree there, but we'll say that that stands for secondary. So secondary oocyte. Okay, now we have something strange going on with humans, right, and some other mammals. So here's our sperm. Let's say this is a Y. Sperm carrying a Y chromosome. And this is a sperm carrying an X chromosome. Now either one of these can fertilize the secondary oocyte. So in humans, it's the secondary oocyte that's fertilized, and then the chromosomes and the DNA in that secondary oocyte will finish going through meiosis 2. So not until after fertilization. But we're going to ignore that for this question because that kind of complicates things and makes it harder to explain how non-disjunction can lead to Klinefelter and Turner syndromes. So let's ignore that for now. And let's just look at what happens when this goes through a normal meiosis. Okay, so if this secondary oocyte underwent normal meiosis, no non-disjunction, and non-disjunction, I should say, failure to separate. So non-disjunction means the chromatids or chromosomes failed to separate during either meiosis 1 or meiosis 2. And it doesn't mean all the chromosomes. It usually refers to one chromosome. So this is just normal separation. We have an X chromosome here and one over here, right? Okay, so this would be normal. And if these were fertilized, this is the second polar body over here. So, and if either of these were fertilized, well, this wouldn't be fertilized, but if this was fertilized, right, then everything would be fine. This is just one X chromosome, and this is what we expect. But, okay, let's say non-disjunction occurs. So how much can I erase here? Going backwards, here we go. Okay, perfect. So, okay, if non-disjunction occurs, well then that means both chromatids will go either to the secondary in this case it's the otid, will go to the otid, or they'll go to the second polar body. Okay, so let's assume non-disjunction occurs and they both go to this otid here. Okay, so now we have two X chromosomes here. If this is fertilized by a Y-bearing sperm, what do we end up with? We end up with a genotype that is two X chromosomes plus a Y. So this, the resulting zygote here, I'll put the Y in here, this will develop into a male with Klinefelter syndrome. Okay, so that's how non-disjunction can lead to a male with Klinefelter syndrome. Again, keep in mind that normally this would be fertilized and the non-disjunction wouldn't occur until after fertilization. But for simplicity, we're just assuming that the otid is the one that's fertilized. So now, how can we end up with Turner syndrome? And we could look at a bunch of different combinations, but the question just asks for Klinefelter and Turner. So let's just look at the combinations or the types of non-disjunction and fertilizations that lead to Klinefelter and Turner. And now we're on Turner. So let's see how much I can erase here. Okay, looking good so far. Okay, now what am I going to do? I'm just going to manually erase the chromosomes inside this otid. Okay, I'm erasing these because we're going to back up and we're going to talk about how non-disjunction can lead to a Turner syndrome in a human. So, okay, so one way that could happen is if these chromosomes fail to separate, and instead of going to the otid, they're going to the second polar body. Okay, so those are in there. I just drew the two X chromosomes outside because I didn't have room in the second polar body. It's too small. But they're in there. Trust me, they are inside the second polar body. And that means we have no X in here, no X's. Now, if this is fertilized by an X chromosome, okay, this zygote here will have one X chromosome, so this would be just one X. So this would be a zygote that develops into a female with Turner syndrome. Okay, so those are examples of how non-disjunction can lead to either Klinefelter or Turner syndrome. You might be wondering what happens if this is fertilized by the Y chromosome. Well, it turns out that zygote would be inviable, so it wouldn't survive. So a human can't survive without, a human needs a zygote needs at least one X to survive. So just a Y chromosome would be lethal.